dish deadline.
Hey, Izzy, what's going on?
Me and Bert tried to experiment. It was a total bust.
Well, don't blame me. It's not my fault.
I mean, literally, it busted everywhere. And now I gotta clean up Dr. Jeff's equipment before he finds out.
How are you gonna do that? I mean, look at all this stuff.
I added hydrogen peroxide with dish soap in this container. So I'm hoping that by the time I add this catalyst, it'll cause a reaction and soap bubbles will go everywhere and I can just clean it up at once.
Okay.
Well, here goes nothing.
Well, I think that qualifies as tons of bubbles.
Look at this mess.
Hey, Dr. Jeff, I can explain. We were just...
This is fantastic.
It is?
By combining two substances, you created a reaction, and that's exactly the lesson I wanted to cover today.
I knew that. That's why I did it.
Awesome. I'm Dr. Jeff Vinegar, and today we'll explore the science behind chemical versus physical changes. But you still gotta clean all this up.
Oh, man.
We'll discover the differences between chemical and physical changes by mixing, burning, and blowing up our test materials. We'll show that both chemical and physical changes are all around us. With Dr. Jeff. Welcome to Labracazam, where we make science make sense. So, what do you guys think? Was Izzy's experiment an example of a chemical change or a physical change?
What exactly is the difference?
Good question, Zoe. In a chemical change, we form an entirely new substance. In a physical change, we don't.
So when we mix things together and a new substance is formed, it's called a chemical reaction.
Let's break it down. Now, to demonstrate... No. This is a banana.
12 years of college, ladies and gentlemen.
If I chop this banana into little tiny pieces like this, is it still a banana? Did we make a new chemical?
No, that's still a banana.
Which makes it a physical change.
Right. But what if we turn the banana into a shake? Next, let's add those berries. And now, the secret ingredient. Hot dog.
Well, it is a source of protein.
Go ahead. So, is this a new substance?
No, all the ingredients are just mixed together, so it's a physical change.
That's right. Now, it's snack time.
It's all yours, Izzy.
Hey, it's chewy, but it's pretty good.
Physical changes often happen when matter changes states. This solid spoon is made of a metal called gallium. Zoe, why don't you take the spoon and stir it into the very hot water?
When you put the spoon into the hot water, it causes it to melt.
Right? But the shiny liquid at the bottom is still the same metal. So it's not a new substance. And it's a physical change.
Correct. It also makes a really good prank. So those were physical changes. A chemical change is different. It forms entirely new substances. Hey, Bert, do you have those chocolate candies?
Those were for an experiment? I thought They were for dessert.
Okay, how about that saltwater taffy?
Those were for an experiment too.
Is there any candy you didn't eat?
Yes, this gummy candy got stuck to my arm.
Thank you. This gummy candy is made of sugar. Let's see what happens when we toss it into this tube of oxidizer. That's a chemical that provides a lot of oxygen to help things burn.
Don't try this at home.
Here we go. Chemical reaction. The gummy candy burned up, forming entirely new chemicals, like this carbon. Gummy candy?
Oh, no thanks.
I'm actually pretty full from that hot dog shake.
Yes, please.
Now it's time to put our new knowledge of chemical versus physical changes to the test.
This first one is a classic, but with a twist.
Get it?
No.
Anyway, we're going to need a drinking glass. Zoe, could you get one, please?
No problem.
For this science trick, you're going to need a bottle of soda, Mentos, fishing line, and scissors. First, you're going to poke a hole in the center of the Mentos and tie fishing line around it. Open up the bottle and lower it in, but don't drop it in. Now just put on the cap to hide the Mentos. And lastly, cut the evidence. Presto!
Oh my gosh, I can't wait to see the look on her face.
Don't try us at home or near any electronics.
Here you go.
Thanks, Zoe. Could you pour a glass of soda, please?
That's it? Really, Doc? Your experiments are starting to get a little bit...
This is everything I dreamed of.
Don't worry, Zoe. You're not the only one that fell for it.
Jeffrey! I said no more science pranks in this house!
So, was the foaming effect caused by a chemical change or a physical change?
Well, when you add the candy to the soda, it created a gas, so I say chemical change.
I think the gas is already trapped inside the soda, so when it's released, it's not a new substance. I say physical change.
Let's take a closer look. I'm going to take a balloon and put the candy inside like this. Then I will put the balloon on top and allow the two to mix. If the gas we're collecting now is also carbon dioxide, then we did not make a new substance. I'll release this gas into this container. Hey, Izzy, please light these candles for us. Carbon dioxide gas is heavier than air. So if you were to pour it onto lit candles, it would displace the air and the candles would have no oxygen, so they would go out. So Zoe, why don't you take this pitcher of gas and carefully pour it here on top of the candles.
I never knew you could pour gas you can't even see.
Whoa, so that means it really was carbon dioxide.
Labracazam. Conclusion. Combining soda and the candy released carbon dioxide gas, but the gas was already in the soda. That means it's not a new substance, it's a physical change.
Don't try this at home.
Let's try another one. This time, we're going to use this yellow liquid and this zinc metal. I'm simply going to take some of the metal and pour it inside. What do you think is happening?
Well, this must be a chemical reaction because there wasn't any gas. I mean, there's a lot now.
But maybe the liquid's just boiling, which will make it a physical change.
Both good theories. Let's try it out with a flame test. For that, you will need a flame. If this gas is carbon dioxide, it will extinguish this flame. If it is hydrogen, it'll make a little pop because it's flammable. And if it's oxygen, this flame will burn brighter. Let's try it out. I'm going to collect some of the gas like this. And once it's full, I'll bring it close to the flame.
It's hydrogen.
Hydrogen, a flammable gas less dense than air, often identified by the characteristic puff when it is burned in a flame test.
So we made a new substance. This is a chemical reaction.
Labracazam. There's a more exciting way to verify this, but we're going to need a lot more gas. Back to the safety zone. Don't try this at home. I'm going to create soap bubbles of hydrogen gas using the hydrogen gas in this balloon and soapy water. Don't try this at home. Here we go. Izzy, I know you love bubbles, so hold up that tray. I'm going to put a lot of bubbles in it. Got it. There. All right, Zoe, you're going to light it on fire. 3, 2, 1. Labracazam!
That was awesome.
Can I be excused to go to the restroom, please?
Our test confirms it's hydrogen. Chemical and physical changes happen to us and around us every day.
To check out some more examples, let's cut to some real-world science. Here I'm whipping up egg whites to make frosting. Since I'm just mixing them with air, it's a physical change. When making toast, intense heat causes the bread to burn, which means chemical change. Hot chemical change. When you turn on a light bulb, the filament glows because it gets very hot, but no new substance is being formed. Physical change. Spoiled milk. The sugars in milk called lactose are converted into lactic acid by microbes, making it sour and barfy. Chemical change. Now let's check in with Zoe with some do-it-yourself. This expired in 2012?
Today, I'm going to show you how to create a secret message using a chemical change. You will need Q-tips, baking soda, a cup of water, a measuring spoon, a regular piece of paper, and blackberries. Start by mixing 2 spoonfuls of baking soda into 1 cup of water. Give that a nice stir for about 15 seconds. It's okay if all the baking soda doesn't dissolve. Next, take your Q-tip and dip it into the liquid. Dab it off on the side of the glass and write a simple message in the middle of the paper. Then let it dry for about 10 minutes. It looks like there's nothing there, but when the water evaporated, it left streaks of baking soda crystals on the paper. The baking soda crystals are white, just like the paper, so you can't see it. To reveal the secret message, we'll use a chemical reaction. That's where the blackberries come in. Carefully rub the berry onto the paper. As the juices come out, smudge them across your entire message. Labracazam! The secret message is revealed thanks to the chemical reaction between the purple pigment in the blackberry and the baking soda. The reaction forms a new substance that's blue. The change only happens when the 2 chemicals are mixed together. Do you think this would work with any other fruits? What if you replace the baking soda with something like salt or sugar? Try it yourself.
Now, let's review. Today, we learned that in a chemical change, we form entirely new substances.
And in a physical change, we don't form a new substance.
Physical changes also occur when matter changes states between solid, liquid, and gas.
Great lessons today, Dr. Jeff.
You look like you could use a refreshment.
Oh, thanks, guys. Nothing sounds better than a nice, hot cup of... Oh, guys.
And the prankster's finally been pranked.
Yeah, I deserve that. Join us next time on Labracazam. I'm Dr. Jeff.
I'm Izzy.
I'm Zoe.
I'm Bert.
And remember, always question, always wonder.